Hello everyone, in this video let us discuss few problems in DC circuits. Number 1. Calculate for each of the circuits shown in figure 1.6 the current flowing in the circuit that each resistor is of 2 kilo ohm. So in figure A we have a single resistors of 2 kilo ohms and a voltage supply of 200 volts. So as we know that the current voltage and resistor relation is nothing but I is equal to V divided by R. We know that V, that is voltage supply, is 200 volts. 200 divided by 2 kilo ohms. Kilo is nothing but 10 to the power 3. So the value is 0.1 amps, which can be written as 100 milliamps. In the second circuit, we have two resistors connected in series, that is 2 kilo ohm plus 2 kilo ohm. So if the resistors are connected in series, we have to add those resistance value. As we know that 2 kilo ohms is nothing but 2000 ohms. So 2000 ohms plus 2000 ohms is nothing but 4000 ohms. So we know the relation I is equal to V divided by R. So here again V, voltage supply is 200 volts divided by, and the series resistance value is 4000 ohms. So the value is 0.05, which can be written as 50 milliamps. Number 2. Calculate the voltage across each of the resistance shown in figure 1.7 and then calculate the supply voltage. So this is the figure. We have 3 resistance which are connected in series. So first resistance is of 2 ohms, second is of 4 ohms, and third is of 6 ohms. So we have to calculate first V1, V2 and V3. Then later we have to calculate the supply voltage V. So they have given the values of all the 3 resistance value and current value. So we know that the relation between voltage, current and resistance is V is equal to IR. So as we are calculating V1, the formula is V1 is equal to IR1. We know I is 2 amps and V is 2 ohms. The value is 4 volts. And similarly, V2 is I into R2, that is 2 multiplied by 4 is equal to 8 volts. V3 is I into R3, 2 multiplied by 6 is 12 volts. So we got the values of V1, V2 and V3. So the addition of all the 3 voltages is equal to the supply voltage. So if we add all the 3, we get 24 volts, which is nothing but the supply voltage. Number 3. For the circuit shown in figure 1.8, find the circuit current given that the supply voltage is 200 volts. So this circuit consists of 3 resistors which are connected in series, R1, R2 and R3, and they have given a supply voltage as 200 volts. Here we need to find the circuit current, which is nothing but I. So as the resistance are in series, we need to add the resistance value to find the equivalent resistance value. So the R is nothing but R1 plus R2 plus R3, that is 40 plus 60 plus 80 is nothing but 180 ohms. So we know the relation of current, voltage and resistance is I is equal to V by R. So V value is nothing but the supply voltage is 200 volts and the equivalent resistance is 180 as we have calculated. So if we do V by R, we get the circuit current as 1.11 amps. Number 4. In the voltage divider of figure 1.10, given that V is 50 volts and the voltage across R2, that is 100 ohms, is 20 volts, calculate the value of R1. So the one way to calculate the value of R1 is, so as we know the supply voltage is 50 volts and the voltage across R2 is 20 volts, then the voltage across R1 is the remaining voltage, that is 30 volts. So 30 plus 20 volts is nothing but the supply voltage 50 volts. So we know that the relation I is equal to V by R. So we are calculating for the current using the resistance R2 and the V2. So we will calculate by using V2 and R2, that is 20 divided by 100, which is nothing but I is nothing but 0.2 amps. So we got the value of I. I is equal to 0.2 amps. So using this we can find out the value of R1. So we know the value of V1, that is 30. So the value of R1 is nothing but V1 by I. So V1 is 30 divided by 0.2, which can be written as 150 ohms. The other way to calculate the value of R2 is nothing but using this formula, that is V2 divided by V is equal to R2 whole divided by R1 and R2, that is the equivalent resistance. So V2 is 20, the supply voltage is 50. We know that R value 100 divided by R1, we are yet to find that, plus 100. So solving this we will get R1 value, that is 150. So this is R1 plus 100. So when we bring the 100 that side, we will get the value of R1. There are two methods to solve this problem. Number 5. Find the supply current of the circuit shown in figure 1.14. The supply current I and the branch current are shown in figure 1. So this circuit, here the resistance are connected in parallel. So as we know that if the resistance are connected in series, the current passing through the resistance will be same, whereas if the resistance are connected in parallel, the voltage across this resistance will be same. So here the supply voltage is 100 volts, whereas the voltage across R1 will also be 100 and R2 will also be 100. So we need to find I, I2 and I1. So as we know that voltage across each resistance is 100, we can calculate I1 with the relation I1 is equal to V divided by R1, that is 100 divided by 20, which is nothing but 5 amps, that is the value of I1. I2 is nothing but V divided by R2, that is 100 divided by 40, which is nothing but 2.5 amps. So the supply current is nothing but the summation of I1 and I2, that is 5 plus 2.5 is nothing but 7.5 amps. Problem number 6. Find the effective resistance and supply current of the circuit shown in the figure 1.15. Here 3 resistors are connected in parallel. The supply voltage is 12 volts. Therefore, the voltage across R1 will be 12 volts, voltage across R2 will be 12 volts and voltage across R3 will be 12 volts. So we need to find the equivalent resistance, that is Req, and also we need to find the supply current. So as we know that the formula for equivalent resistance is 1 by R is equal to 1 by R1 plus 1 by R2 and 1 by R3. So as we have 3 parallel resistance, we are calculating for the 3 resistance. So this is 1 by R. So 1 by R is equal to 1 by 8 plus 1 by 6 plus 1 by 4. These are the value. This is for 1 by 8, 1 by 6 and 1 by 4. So therefore 1 by R is equal to 0.541. So therefore the total resistance, that is R, is equal to 1.85 ohms. So this is the equivalent resistance Req. Then we need to find the supply current. Supply current, we know the current, voltage and resistance relationship, that is I is equal to V by R. We know that supply voltage is 12 and we found out the equivalent resistance, that is 1.85. Calculating this, we get the current 6.49 amps. Problem number 7. A current of 10 amps is divided between 2 resistors in the circuit shown in the figure 1.16. Find the current in each of the 2 resistors. So here we need to find I1 and I2. So as this is a parallel resistance, current in each resistor will be different. Only the voltage across them will be same. So to find I1, this is the formula. So how did we get this formula? I will show you. We know that equivalent resistance, if there are 2 parallel resistors, right? So this is for equivalent resistance will be R1 into R2 divided by R1 plus R2. So this is the equivalent resistance. So we need to find the current I1. So we will simplify this R1. So this will be equal to V by I1. This R1 will be V by R1. So we remaining as it is, we will write that. So R2 divided by R1 plus R2. So this side R will be there. So if we bring I here and R this side, so we will get I1 is equal to V by R and R2 divided by R1 plus R2. So V by R, we know it's I. So I1 is equal to I into R2 divided by R1 plus R2. This is the formula to find current I1 if there are parallel resistors. So this is what it is written here. So we know the supply current, that is 10 amps, and we know R2, that is 2, R1 is 2 and R2 is 2. So simplifying this, we get I1, it is 5 amps. So we know the supply current. So if we subtract 5 amps from the supply current, we will get I2, that is 5 amps. So thus we see that equal resistance share the supply current equal. So as the value of the resistance are equal, so we can tell that the current shared by them will also be equal. That is what it is proving here. Problem number 8. A current of 10 amp is divided between two resistors in the circuit of figure 1.17. So find the current in each of the two resistors. So here we need to find I1 and I2. In the previous problem, we got to see that R1 and R2 were equal, that is 2 ohms and 2 ohms. Here the two resistance value are different. Here R1 is of 2 ohms and R2 is of 4 ohms. So therefore the current will not be equal. I2 and I1 will not be equal. So we need to calculate. So first we will calculate I1. So from the in the previous problem, I have showed you how this formula has been derived. So using this formula we can calculate I1. We know the supply current, which is 10 amps, and resistance value of R2 is 4 ohms and resistance value of R1 is 2 ohms. So simplifying this, we get I1 is equal to 6.66 amps. So by subtracting I1 from the supply current, we get I2, that is 3.34, or you can use the formula what we have used to calculate I1. So that will be same as 3.34 amps. So from this we can say that thus it is seen that the lesser the resistance, greater its share of the supply current. So if the resistance value is less, then the current value will be more. So if the resistance value is more, current passing through that resistance will be less. Problem number 9. A coil of 12 ohms resistance is in parallel with 20 ohm resistance. This combination is connected in series with the third coil of 8 ohms resistance. The whole circuit is connected across a battery having an EMF of 30 volts and an internal resistance of 2 ohms. Calculate the terminal voltage of the battery and the power in the 12 ohm coil. So this is the circuit where 12 ohm and 20 ohm resistance are in parallel, which this combination are in series with the 8 ohm. So this 2 ohm is the internal resistance of the battery with the supply voltage of 30 volts. So this is current I. First we need to find the terminal voltage. Terminal voltage is nothing but the supply voltage minus the voltage drop of the internal resistance. So to find the voltage drop across this resistance, we need to have the value of I. To find the I, first we need to calculate the equivalent resistance of all the 4 resistance, that is 12 ohm, 20 ohm and 8 ohm and 2 ohm. So as this both are in parallel, first we need to find the equivalent resistance between the point A and point B. So the resistance of the parallel combination between A and B is RAB. So we know the formula. So 1 by RAB is equal to 1 by 12, that is the ohm of first resistance, the resistance value of the first resistor. The resistance value of second resistor is 20, therefore plus 1 by 20, which is equal to 8 by 60. Therefore the resistance between RAB is 7.5 ohms. So then all the remaining resistors are in series, so we can add 8 and 2 with 7.5. So by adding 7.5, 8 and 2, we will get the equivalent resistance, that is 7.5 ohms. So the total, now we can calculate the current. So we know the current, voltage and resistance relation, that is I is equal to V by RT, that is equivalent resistance. So we know the supply voltage is 30 and the equivalent resistance is 17.5. So therefore the supply current or the circuit current is 1.714 amps. So using this we can find the internal voltage of the battery. So we know the supply voltage, we know the internal resistance is 2 ohm. Therefore multiplying it into the circuit current, we get the internal voltage drop. So subtracting this from the supply voltage, we get 26.572 volts. So then the second point, that is the power in the 12 ohm coil. So this is the 12 ohm coil. So we need to find the power, that is power is nothing but V into I. So power formula can be written as V into I, or power can be written as I square R, or power formula can be written as V square divided by R. So these are the three formulas. So this is the easiest one, as we know the current and we can find the voltage across the 12 ohm resistance. So first we will find the voltage across AB, that will be I into RA, that is nothing but 12.855 volts. So using this and using this formula, that is P is equal to V square by R, we can find out the power across 12 ohm resistance, that is 12.855 square divided by 12, that is 12 ohm coil. Therefore the power will be 13.77 watts. Problem number 10. If the total power dissipated in the circuit shown is 18 watts, find the value of R and its current. So here in the circuit we need to find the value of R and current. So that is, let us say this is I2, let us name this as I1. So we need to find the value of R and I2. So R and I2. So we know that power is 18 watts. So using this we can find the equivalent resistance, that is we know the power formula, that is P is equal to V square divided by R equivalent. R equivalent, as this both are in parallel and this both are in parallel, together combination they are in series. So we can find the equivalent resistance using this formula. We know that power is 18 and voltage is 12. So this will become 8 ohm, as 12 square is 144, which is divided by 18 is 8 ohms. So we got that R equivalent is 8 ohms. Using this we can find out the value of R. So we know the equivalent formula, that is 8R divided by 8 plus R plus 4 into 16 divided by 4 plus 16. So by simplifying this we will get the value of R, which is nothing but 12 ohms. So from this we got R value, that is 12 ohms. So next we need to find I2. So before finding I2, we need to find the value of I. So the total current is equal to V by R equivalent, that is 12 by 8, which is nothing but 1.5. So I is equal to 1.5 amps. Now we know the current formula when the resistors are in parallel. So I2 is equal to I into R1 divided by R1 plus R2. So here I is nothing but 1.5, R1 is nothing but 8 plus we found out R2 is nothing but 12. So using this we will get 12 by 20, which is nothing but 0.6. So the I2 value will be 0.6 amps. So the resistance value is R and its current is 0.6 amps and the total current is 1.5 amps. Problem 11. A resistance of 10 ohms is connected in series with two resistance each of 15 ohm arranged in parallel. What resistance must be shunted across this parallel combination so that the total current shall be 1.5 amps and 20 volts applied, that is supply voltage is 20 volts. So this is the figure. So as we can see here, three resistance are in parallel and this combination of three resistance are in series with another resistance with 10 ohms. They have given supply current, that is 1.5 ohms, and supply voltage, that is 20 volts. So they are asking the value of R, that is resistance which is parallel with this two resistance. So we know that supply current is 1.5 amps and the resistance which are in series is 10 ohms. So we know that the voltage across all the three resistance will be equal. So the supply voltage is 20 volts. Let us find the voltage across 10 ohm resistance. So we know the formula is equal to V is equal to R into I. So here I is 1.5 and R value is 10, nothing but 15 volts. So we got the voltage across 10 ohm resistance. So the voltage across this parallel resistance will be this resistance minus, this voltage minus this voltage. Therefore VAB is equal to 20 minus 15. Therefore the voltage of all across all these three resistance will be 5 volts. Now we will calculate I1 and I2 using this voltage. I1 formula is nothing but V by R1. So VE we found out, that is 5 and R1 is 15. So this is similar to I2. So nothing but 1 by 3, that is given as here. So both I1 and I2 we found out, that is 1 by 3. Now let us find I3. So we know that I is equal to I1 plus I2 plus I3. So therefore I3 is equal to I minus I1 plus I2. So by simplifying this, we will get I1 as 5 by 6 amps. Now we know I3 and V. So we need to find out R3. So R3 is equal to V by I3. V is 5, I is nothing but 5 by 6. So this 5 cancels and this 6 goes up, therefore 6 ohms. That is given as 6 ohms. So problem number 12. Determine the value of R if the power dissipated in 10 ohm resistance is 40 watt for the circuit shown in 1.21. This is the figure 1.21. So they are telling to find the value of R where the power across the 10 ohm resistance is 40 watt. So we know the formula of power. P is equal to I square R. So using this we can calculate the value of I as we know R. So I square is equal to P by R. They have given power that is 40 and we know R value that is 10. We will get 4. So by sending the square that side, the I value will become 2 amp. So we got the current that is 2 amp. So let us find the voltage across this resistance. Let us call V1 and let us call this voltage as V2. So as we know the supply voltage is 50. So let us calculate V1 is equal to 2 into 10, that is 20 volts. So we got the value of 20 volts. So the supply voltage is nothing but V is equal to V1 plus V2. We know V1 is 20 and we need to find out V2. So therefore V2 is equal to 30 volts. So if resistance are in parallel, then the voltage across each resistance will be equal. Therefore the voltage across R will be 30, the voltage across 40 ohms will be 30, the voltage across 80 ohms will be 30. So by this we can easily find out the value of I1, I2 and I3. We know the starting formula is nothing but I is equal to I1 plus I2 plus I3. So we need to find I1 is equal to V divided by R1, that is 30 divided by 80. So we got I1 value that is 0.375 amps. Let us find out I2 in the same way. 30 divided by 40. So we got the value of that is I2 0.75 amps. Now let us calculate I3. I3 is nothing but I minus I1 plus I2. So I1 is 2 and this total is 0.375 plus 0.75. So calculating this we get I3 is equal to 0.875 amps. Using this we can calculate the value of R, that is 30 divided by 0.875, nothing but 34.3 ohms. This is what it has given. Problem number 13. In the circuit shown, find the value of resistance R when the power consumed by the 12 ohm resistance is 36 watt. So here there are three resistance which are connected in parallel, and this combination resistance is connected to a resistance R in series. So here we have to find out the value of R. They have given the power across R1. So first let us find RAB, that is equivalent resistance. So as these three are connected in parallel, we will find the equivalent resistance across it. By calculating using the formula, we will get 6 ohms, that is 12 into 18 into 36 whole divided by 12 into 18 plus 18 into 36 plus 36 into 12. By simplifying that, we will get the value RAB is equal to 6 ohms. So we can also simplify the figure by this. So there are two resistors now which are connected in series with a supply voltage of 60 volts and the current I. So this is RAB with 6 ohms and R. We have to find out R value. So they have given the power across R1 as 36 watts. So we know the formula P is equal to V square divided by R. So as they have given for R1 resistance, we should have VAB whole square divided by R1. So that is nothing but VAB square divided by R1 value is nothing but 12. So power is 36. So 36 into 12 is equal to VAB square. So VAB square is nothing but 432. Now VAB will be square root of 432. That is nothing but 20.78 volts. So now we have got the voltage across point A and point B. Now let us find I1, I2 and I3 using this voltage. So I1 is equal to VAB divided by R1. I2 is VAB R2. I3 is VAB divided by R3. So we know the value of VAB and R1. Now calculating this, we will get 1.73 amps. Calculating this, we will get 1.15 amps. Calculating this, we will get 0.57 amps. So we will get the supply current by adding all the three. That is nothing but 3.45 amps. So this is the formula to calculate the supply current. Now let us find, in the question they have said that we have to find the resistance R. So now let us find, we got I is equal to 3.45 and voltage across this is nothing but 20.78. So this is V2 we have to find. So nothing but we have formula I is equal to V by R. So we know V is 60 and R is 6 plus R. R equivalent R. So if we put 6 plus R and 60 by 3.45, we will get, by simplifying this, 11.4 ohms. This is what? This is a simplification. The final answer is 11.4 ohms. So that is nothing but 11.4. Problem number 14. In the circuit shown in the figure 1.23, determine the current supplied by the 100 volt source and the voltage across 6 ohm resistor. So this is the circuit, this is the figure 1.23. So they are telling to find the supply current, that is I, and also the voltage across 6 ohm resistor. So first we need to find I. So that can be found out by the equivalent resistance. So first we need to find the equivalent resistance across this parallel resistance, that is 6 ohm and 3 ohm. That would be 2 ohm given here, and again this 2 ohm will be in series with 3 ohm and 5 ohm, which will be 10 ohm. So this 10 ohm, so this will be equal to 10 ohm, and this 10 ohm will be in parallel with this 10 ohm, which equivalent will be 5 ohms, and this 5 ohms will be in series with this 5 ohm, making the circuit so this will be equal to 5 ohm. This will be equal to 10 ohm. This 10 ohm will be again parallel with this 10 ohm, making 5 ohm, and that 5 ohm will be in series with this 5 ohm equivalent, making R equivalent is equal to 10 ohm. Using this we can find out I is equal to V by R equivalent, that is nothing but 100 divided by 10. So I is equal to 10 amp. So the first is the current supply by the 100 source volt is nothing but 10 amps. So next we have to find the voltage across the 6 ohm resistance. So this is the 6 ohm resistance. So we know current is 10 amps. So then the current will start dividing here. As we know, this part is 10 ohms and the other another parallel resistance is 10 ohms. So the current will divide equally. So this will be 5 amps, this will be 5 amps, and again the current at the point B will divide. So as we know, this part is 10 ohms and this resistance is 10 ohms. So again the current will divide equally. So here it is 5 amps, so it will be 2.5 amps, and here it will be 2.5 amps. So I'll write this parallel resistance here. So this 6 ohm and this 3 ohm. So this is 6 ohm, so this is 3 ohm. So the current coming here is 2.5 amps. So let us take, this is I1 and this is I2. So here you can see the ratio. Here the current will divide according to the value of resistance. So according to this ratio, the current here, so we can see the ratio is nothing but 3:6. This is 3 ohms and 6 ohms, that is nothing but 1:2. So the current here will be of 1/3 and here it will be 2/3. So using this ratio we can calculate. So let us calculate the current I1 here, that is current 2.5 into the ratio. So we are calculating across 6 ohms, that is the ratio is 1/3. So 1 divided by 3, 2.5 by 3, and again current 2 is equal to 2.5, 2 divided by 3, being what 5/3. So we should find the voltage across 6 ohm resistance. V 6 ohm is equal to I1 into, we know that 6 ohm, so nothing but 2.5 by 3 into 6 is nothing but 5 ohms, 5 volts. So voltage across 6 ohm is nothing but 5 volts. Problem number 15. In the circuit given below, figure 1.27, find the value of DC current through RL by using a Kirchhoff's law. There are two Kirchhoff law, one is current law and another is voltage law. Current law says that, so in any network of wires carrying current, the algebraic sum of all the currents meeting at a point is 0, or it can also be stated as the sum of incoming currents towards any point is equal to sum of outgoing currents away from that point. So that is current law. So if this is a point, if there are many incoming, so this is I1, this is I1, this is I2, this is I3, 5, 10 and 15, this will wind up as 30. So the outgoing should be 30 amps. So the value of incoming should be equal as outgoing, or at the point it should be 0. So at this, let us say it as A, so it should be 0.
So the Kirchhoff voltage law states that the algebraic sum of all the EMF plus the algebraic sum of voltage drop is equal to 0. So that is EMF plus voltage drop is equal to 0. So here we will use the second law, that is Kirchhoff voltage law. So here we will first write the indication. So this will be plus minus plus minus according to the direction, plus minus. So we have given. So first, so we will take from this direction. So first we will have I1 R1, this is the Kirchhoff law, plus I1 I2 into RL, and as this direction is this, we are taking from this, it is minus, which is equal to 0. So this states that the algebraic sum of all the EMF, this is EMF EM, and sum plus the voltage drop is equal to 0. So substituting this, we know that R1 is 12 and I1 RL is 6 and E1 is 84. So we will get this equation. So we will take it as 1. So we have two supply, E2 and E1. So again we will find out for E2. So here we will find out for E2. Again I'll write the indication plus minus and plus minus plus minus. So here we will write we will take from this direction. So later we took from here. So here, as this resistance will have a minus sign at the end, it will be like minus I1 plus I2 whole multiplied by RL minus I2 R2 and plus E2. So simplifying this, we will get the equation number 2. So taking into consideration equation 1 and equation 2, we will simplify. So this is equation 2, this is 1. So simplifying this, we will get I2 is equal to minus 1. So minus 1 indicates that the direction of the current flow is in the opposite direction as what we have assumed. So the negative sign of the current I2 means that it is flowing in the direction opposite to the. So here you can see the I2 is flowing from C to F, but actually it is flowing from F to C as it is negative sign. Here also it is flowing from D to E as it is negative. So then we will substitute I1 in any one of the equation. So we will take equation number 2 and substitute I1 and we will find out, substitute I2 and we will find out I1. So I1 is nothing but 5 amps. So later we can calculate I3. So that is the summation of I1 and I2. That is equal to 4 amps. So I3 flows in a direction assumed from D to C. So here we need to find the DC current through RL. So we that is nothing but I3. We have found it as 4 amps. Problem number 16. Two 12-volt batteries with internal resistance of 0.2 ohm and 0.25 ohm respectively are joined in parallel and a resistance of 1 ohm is placed across the terminals. Find the current supplied by each battery. So this was the figure which was explained in the question. So here we have two batteries of 12 volt and we have an internal resistance of one is of 0.2 ohms and another one is 0.25 ohms, and 1 ohm resistance is placed across the terminals. So we have to find the current supplied to the each battery. So as we know that current from this battery, let us take it as I1, and from this we'll take it as I2. So that two currents will be added to the resistance, that is I1 plus I2 across the 1 ohm resistance. So let us use Kirchhoff voltage law for this loop. The loop is A, B, C, F and A. So for loop A, B, C, F and A, let us write the Kirchhoff law, that is 12 minus I1.2 minus I1 plus I2 is equal to 0. So when we simplify this, we'll get as 1.2 I1 plus I2 is equal to 12. So this is the equation. This is the equation 1. So let us consider loop F, C, D, E, F. So using Kirchhoff law again, 12 minus 0.25 I2 minus I1 plus I2 is equal to 0. When we simplify this, we'll get I1 plus 1.25 I2 is equal to 12. So this is a second equation. So using equation 1 and equation 2, we can substitute like this. So we will multiply equation 2 to 1.25. We will get this equation, and simplifying this, we'll get I2 as 4.8 amps. So using this I2, we can find out I1. That is, we know the equation I2. So we'll substitute any one value here. So let us substitute here 1.2 I1 plus 4.8. So when we send 4.8, that's it, we get I1 is equal to 12 minus 4.8 divided by 1.2. So this would be like 6.8. So simplifying, we'll get I is equal to 6 amps.
Problem number 17. In this problem, they have given a circuit where we have to find E1, E2 and I. So they have also given the power dissipated in 5 ohm resistance, that is 125 watt. So using first law, we can find that the current flowing through the 5 ohm resistance will be I plus 2.5. So this is I and this is 2.5. So this current will flow in the 5 ohm resistance. So using Kirchhoff's second law, that is voltage law, we will find the E values. So first, for the loop A, B, C, F, A, we'll first find the loop. So E1 minus 3I is equal to E2 minus 2 into 2.5. So we'll get it as E1 minus E2 minus 3I is equal to, so this will be a 5. So this will be first equation as given here. Next loop is FCDE F. So we'll again find the loop. So E2 is equal to 2 into 2.5 plus,
So 5 into I plus 2.5. So this will be the second equation. When we simplify this, we'll get 5 plus 5I plus 12, we'll get 12.5. So further simplifying, E2 will get 5I plus 17.5. So this is our second equation as given here. So further they have given that the power across through the 5 ohm resistance across 5 ohm resistance 125. So we know power formula VI. If we further simplify this, we will get I square R. So we know I is nothing but I plus 2.5 square and R is 5. So we know power 125. So when we send this to this side, we will get I plus 2.5, which is on square. We will get 125 divided by 5 is 25. So when we send the square root the other side, that is 25, we will get 5. So I is equal to 5 minus 2.5. So I is nothing but 2.5 amps. So when we substitute this I value here, this will become 7.5, and when that goes that side, we'll have. So when we substitute another I here, we'll get 12.5, which is nothing but E2 will become 30 as given here. So once we get E2 30, we'll simplify this in the equation number 1 and we'll get E1 as 32.5. So final answer will be 32.5 volts, 30 volts, and I is 2.5 amps. Problem number 18. So two storage battery A and B are connected in parallel to supply a load of 0.3 ohm. The open circuit EMF of A is 11.7 volts and B is 12.3 volts. The internal resistance of 0.06 ohm and 0.5 ohm respectively. So find the current supply. So they have explained the circuit. So finally we have to find I. So this I is nothing but I1 plus I2. I1 is the current from the battery A and I2 from battery 2. So we know that I is equal to I1 plus I2. So using Kirchhoff's second law, that is voltage law, so we will find one loop, that is this loop. So that will be A, B, C, D, A. So when we apply Kirchhoff's second law, we will get it as 11.7 minus 0.06 I1 is equal to 12.3 minus 0.005 I2. So this is the equation. When we simplify it, we will get when we simplify this, we will get 0.06 I1 minus 0.05 I2 is equal to minus 0.6. So this is the equation 1 which has been written here. So this is the equation 1. The same Kirchhoff's second law for the loop 2. That may be a loop 2 which is going as I am showing. So this is loop 2. So that will be of F, B, C, G. So this is across F, B, C, G, F. So when we write, we'll get 11.7 minus 0.06 I1 minus 0.3 I is equal to 0. So when we simplify this also, we'll get 0.36 I1 plus 0.3 I2 is equal to 11.7. So this is a second equation. So using equation 1 and equation 2, when we simplify by multiplying 6 to equation 1, we will get equation 1 as this, and simplifying those two, we will get I2 value. I2 value is 25.5 amps. So using this I1, we will substitute in any of the one equation, that is 1 or 2, to get I1 value. So I1 will be 11.25. So once we get I1 and I2, we know I is nothing but the addition of I1 and I2, that is nothing but 36.75 amps. So we have found out the current which will flow across 3.3 ohm resistance. Problem number 19. Find current in 15 ohm resistor, voltage across 18 ohm resistor, and power dissipated in 7 ohm resistor. So this is the figure. So first we have to find the current across this 15 ohm resistor. So that will be I1 plus I2. So let us call this as IE. So next, so first we have to calculate IE. So next we have to calculate find the voltage across 18 ohm resistor. So let us call this as V18. So V18 we have to find out. Third is power dissipated at 7 ohm resistance. So let us call it as P7. So P7 we have to find. So these three we have to find from this figure. So first we will find the resistance across this parallel combination, that is A and B. So equivalent resistance across A and B is RAB, which is 9 into 18 divided by 9 plus 18 will be 6 ohm. So this is 6 ohm. So now we'll use the Kirchhoff voltage law, that is second law, from the meshes. First mesh is P, Q, R, U, P. So the mesh will goes like this. So when we write the mesh equation, we will get 10 I1 is equal to 9 I2. So this is the first equation. So next the mesh is URSTU. So this mesh goes like this. So when we simplify, we'll get the second equation as shown here. So multiplying 3 to equation number 1 and multiplying 2 to equation number 2, we can simplify and get the I2 value. So I2 will be 3.33 amps. So using this, simplifying this value in any one of the equation, that is equation 1 or equation 2, we will get I1 as 3 amps. So as we know, EI, equivalent current, is I1 plus I2. So the total current will be 6.33 amps. So we found out the first one, that is IE. So next one is we have to find out the voltage across 18 ohm resistance. For that we need I4. To find I4, using I1, we will simplify I3, that is I1 into 18 by 9 plus 18. I3 will be 2 amps. Using this, we know that I1 minus I3 is I4. We will get I4 as 1 amp. So voltage across 18 is 18 into I4, that is 18 volts. Next is P7. So power will be I2 square into 7. So we know I2 square, that is 3.33. So simplifying that, we will get 77.62 watts. This is the power it has given here. Problem number 20. Determine the magnitude and direction of the current in the 2 volt battery as shown in the circuit below. So magnitude is nothing but the value of current, and we have to find the direction of the current. So first the 2 volt as shown in the figure. So they are telling us to find the value of the magnitude of I2 and which direction it is flowing. So using Kirchhoff first law, we can tell that this 2 volt is producing I2 and this 4 volt is producing I1 and this 3 volt producing maybe I3. So this will be equal to I3 and this will be again equal to I3. So here I1, it's splitting into I2 and I3, or I1 is I1 minus I2, which is I3 to the third branch. So we have shown the direction. Now we have to find the magnitude of I2, that is the current in the 2 volt battery. So we will use Kirchhoff's second law, that is voltage law. So this loop and this loop. So first loop is nothing but A, B, C, F, A. So for this, when we simplify, we will get 4 minus 2I1 minus 3I2 plus 2 is equal to 0. So when we further simplify this, we will get 2I1 plus 3I2 is equal to 6. So this is the first equation, right? So this is the first equation as shown here. So when we take the loop F, C, D, E, F, again we'll have the loop F, C, D, E, F. So this is the second loop. So this will be equal to 2 minus 3I2 is equal to 3 minus 1.5 to I1 minus I2. So when we further simplify, we will get equation 2. So multiplying 3 to equation 1 and multiplying 4 to equation 2, we will get this 2 as equal, so that when we simplify it, we will get I2. I2 is nothing but 0.52. So we have found the direction as shown in the circuit, and also we have found out the magnitude for the current in the battery, 2 volt battery, that is 0.52 amps. Problem number 21. For the network shown below, determine all the branch currents. So this is the network. So we have to find the branch current, that is branch current of BA, branch current of AC, branch current of CB, BO, AO, CO. So before that, we will indicate the currents using Kirchhoff's first law of the junction. So let us name the current from CB as I1, and it is divided, and the branch current BO is I2 and branch current BA is I1 minus I2, branch current AC is I1 minus I2 minus I3, branch current AO is I3, branch current OC is I2 plus I3. So this we have done applying Kirchhoff's first law to all the junctions. So now we will use the Kirchhoff's second law, that is voltage law, and use law to the loops. So there are 3 loops, that is BOC, BAO and AOC. So we will use the Kirchhoff's second law. So first we will take BOA loop. So from the circuit we can say that minus I1 minus I2 minus I2 I3 plus 4I2 is equal to 0. If simplify this is what we get, equation 1. So this is equation 1. And for the loop AOC, if we simplify, this is what we get, the second equation. And for the third loop, that is COV, when we simplify, we will get the third equation. So using this equation, we will simplify further. So first we will multiply 2 to the equation 1. So when we multiply it will be almost similar to equation 3. So using that we will add the both equation and we will get a fourth equation, that is 10i2 plus i3 is equal to 5. Then again we will multiply 2 to the equation number 2. So this is equation number 2, we will multiply, and 1.5 to the equation number 3. So when it will be similar, and we will start adding those two equations to further simplify, and we'll get this equation 30i2 28i3 is equal to 15. Then we will multiply again 3 to the equation 4, which will be similar to the equation above, and if we subtract the both equation, we come to know that I3 is 0. So therefore the branch current of AO, so branch current AO, that is I3, will be 0 amps. So using that we will simplify this in one of the equation and we'll find I2. Then the I2 will be of 0.5 amps. Then further we know that I2 and I3 will further simplify in one equation and we'll find out I1. So once we find out all the three, we'll simplify or equate in all the branch current equation and find the branch current. So we know that CB is I1, which is nothing but 2.5 amps. Next BO is I2, which is nothing but 0.5 amps. Next is BA is I1 minus I2, that is 2.5 minus 0.5 is nothing but 2 amps. Next AO is, we know that I3 is 0, therefore the branch current will be 0. Next is AC branch current, that is I1 minus I2 minus I3. This will be 2.5 minus 0.5 minus 0, that will be equal to 2 amps. Next OC will be I2 plus I3, that is nothing but 0.5 plus 0, that is 0.5 amps. This is how we find the branch current of this given figure. Problem number 22. Find the value of R and the current flowing through it in the circuit given below when the current in the branch OA is 0. So first we need to find R. So R value, that is a branch current of CO, and next we have to find the current flowing through it. So from the figure we can see that the current flowing through R is nothing but I2. So we have to find this two, R and I2. So they also given that the branch current of OA is 0. So there is no current flowing here. So first we will indicate that the branch current of BA is I1 and BO is I2. So then we will use Kirchhoff first law, that is current law. Applying this law to the junctions of B, A, O, we will write the current flowing. So from CB the current is I1 plus I2. It will split to I1 in branch BA, I2 to branch BO. As there is no current flowing from A to O, the I1 will flow to branch AC, and again O to C will be I2 and the summation to branch C and B. So this using applying Kirchhoff to the Kirchhoff first law to all the nodes. Then let's use the Kirchhoff second law for all the loops, that is the voltage law. First we will take this law and write the equation, that is minus 4i plus 0. As the branch current is 0, the voltage drop will also be 0, plus as the current is opposing, it will be plus 1 into I2. Further simplifying, we will get equation 1, that is I2 is equal to 4 times I1. Next we will write the second loop, Kirchhoff voltage second loop, that is minus 1.5 I1 plus, as it is opposing, we will write plus R I2. So is equal to 0. So we got two equations, equation 1 and equation 2. So we will simplify this equation number 1 in equation 2. When we simplify equation number 1 in equation 2, this is what we get, and further simplification we will get R value. So R is nothing but 0.3 0.75 ohms. So we have found out R, the value of R, and we have to find the current flowing through that resistor. So next we have left one more loop. So we will also apply the Kirchhoff second law here. So when we apply minus 1.5 into I1 plus I2 plus 10 minus 1.1 I2 minus R I2 is equal to 0. So here we know the value of R I2. So this is the value of R and I2. So we will apply this in this equation, and further some simplification we will finally get I1 value. Once we get the I1 value, we will substitute in equation number 1. Once we substitute, that is nothing but I2 is nothing but 4 times I1. So we will multiply this into 4. We will get 3.1 amps. That is the final answer. So we got the value of R, and the current flowing through the resistor that is I2 is 3.1 amps. Problem number 23. In the network shown in figure 1.35, determine all branch currents and the voltage across 5 ohm resistance by mesh current method. So this is the figure. So we have to find the branch current, that is IA, IB and IC. So first we have to find IA, next is IB and IC, and next we also have to find the voltage across 5 ohm resistance. So this is the 5 ohm resistance. So let us call this voltage across 5 ohm as V5. So we have to find all this 4. So first let us apply the Kirchhoff voltage law to the mesh, both mesh. So let us let the loop currents be I1 and I2. So this is the loop. So this is another loop. When we apply Kirchhoff voltage law, we will get 50 minus 3 IA minus 5 IC minus 6 IA. So we will further simplify this, and we'll get one equation, that is nothing but 14 I1 minus I2. So we have taken a loop current, right? So this is nothing but we have to apply loop current. So when we apply loop current, 50 minus 3 I1 minus 5 I1 minus I2 minus 6 I1 is equal to 0. So once we simplify this, we will get the equation 1. And for the same thing, for the mesh BCDB, we will apply the Kirchhoff voltage law as a loop current I2. So we will get minus 2 I2 minus 8 I2 minus 5 into I2 minus I1 minus 25. So once we simplify this, we will get another equation number 2. So solving equation 1 and 2, we will get I1 and I2. So once we get I1 and I2, we can easily find out IA, IB and IC. So as we know that IA is nothing but I1. So therefore IA is nothing but I1, which is nothing but 3.378 amps. And IB is nothing but minus I1. So minus I2. So minus I2 is minus plus. So IB is nothing but 0.54. So from the figure we can say IC is nothing but the addition of I1, IA and IB, that is nothing but 3.918 amps. So once we get IC, the voltage across V5 is nothing but V5 is equal to 5 into IC, that is nothing but 3.918 into 5. So V5 is equal to 19.59 volts. So nothing but 19.59 volts. So we have found out all the 4 values which are required. Problem number 24. A 250 volt lamp is rated to pass a current of 0.3 amps. Find its power output, that is nothing but P. Now, if the second similar lamp is connected in parallel with the first lamp, find the supply current required to the given same power output in each lamp. So first we'll write for the first thing, that is 250 volt lamp. So this is 250 volt lamp where the current is given as 0.3 amps. So we have to find out, that is V is equal to V into I, which is nothing but 75 watt. So this is nothing but 75 watt. So similarly, I'll write two lamp which is in parallel. So this is one lamp. This is another lamp. This is the supply current, that is I1. So I'll write the current here as, so they have said that similar lamp is connected in parallel with first lamp. Find the same power output. So if it has the same power output, current should also be same. Voltage should also be same. So this is first lamp. So same power output is 75 watt. So if it's 75, voltage will also be 250. As it is in parallel, current will also be 3 amps. So this is second. So the supply current will be 0.6 amps. This is when the lamps are connected in parallel. The same problem, this is the 25th problem. Calculate the power if the lamps are connected in series. So lamps I'll indicate in resistor. So this is one lamp. So current is given as 3 amps. So voltage across it is equal to 250. So power is 75 watt. So what is the resistance value? So that we will find out using this equation, that is nothing but 833.3 ohms. So what if this has been connected, two lamps are connected in series with the same resistance, 833.3 ohms, 833.3 ohms. So the voltage and current, so when the resistance are there, so when we add the equivalent resistance, we'll get 1666.60 ohms. When we simplify, we will get the current as 0.15 amps. Therefore the power will reduce to 37.5 watts. So as you can see, when the lamps are connected in series, the power dissipated from the lamp will be less, that is 37.5 watts. Problem number 26. A current of 4 amp passes through a 10 ohm resistor. So calculate the power developed by the resistor, and the second one is calculate the energy dissipated in 3 minutes. So we have to find the power and energy. So let us assume one 10 ohm resistor. So this is 10 ohm where the current of 4 amp is passed. So first we need to find power. Power is nothing but I square R. Here I is nothing but 4 and R is 10. So power is nothing but 160 watt. So once we get the power, we have to multiply this power into time to get the energy, that is energy W is equal to P into T. So we can take this T, they have given it as 3 minutes. So if we take it in seconds, it's 180 seconds. So if we multiply 160 into 180, that is 160 into 180, we get 28,800 joules or watt per watt second. So 28,800 watt second is the energy dissipated in 3 minutes. So problem number 27. A heater is given a current of 10 amp from a 250 volt source for 15 hours. Determine the energy consumed by the heater in kilowatt hours. So in previous we have calculated in watt second. Now we have to calculate in kilowatt hours. So they have given that a heater. So let us assume this as an heater which is connected to a voltage source of 250 volts, and the current to the heater is given as 10. So first we need to find power. Power is nothing but V into I, which is nothing but 2500 watt. So when we convert this into kilowatt, we get 2.5 kilowatt. So as we know, energy dissipated is power into time. So W is equal to power. That is, so we need in kilowatt, we got power in kilowatt, that is 2.5. Time is 15 hours, it's already in hours. So into 15, that is nothing but 37.50 kilowatt hour. Problem number 28. For the circuit shown in figure 1.36, that is this figure, determine the power developed by each resistor. So first, to find out the power developed by each resistor, we have to find I1 and I2. So for I1 and I2 we have a formula. So for I1 we have I1 is equal to I into R2 whole divided by R1 plus R2. So we know I is 12, R2 is 5, and the sum of R1 and R2 is 15. So this will become 1 by 3 and I1 will become 4 amps. Once we get I1, we can get I2 easily, that is 8 amps, because total is 12 amps. So once we get I1 and I2, we can easily find P1 and P2. So this is I square I1 square R1, that is 16 into 10 is equal to 160 watt. Same thing P2. I2 is 8 square and R2 is 5, that is 320 watt. So P1 is 160 watt, P2 is 320 watts. Problem number 29. Two resistors connected in parallel across 100 volt DC supply take 10 amps from the line. The power dissipated in one resistor is 600 watt. What is the current drawn when they are connected in series across the same supply? So they have given the diagram is shown as what they have explained in the question. So two resistors are connected in parallel where I is of 100 volts, where it take 10 amps from the line. So I will be 10 amps. So in that, one of the power dissipated in one resistor is 600. So let us take R1. So here the power dissipated will be 600 watt. So if R1, the power dissipated in one R1 resistor is 600 watt, so we can find I1. How? Because we know P1 is equal to V into I1. So we have got, so same we can write I1 is equal to P1 by V. So we know power is 600 and voltage is 100. So we will get 6 amps. Once we get I1, I2 we can easily get by substituting in this formula, that is 10 minus 6. So I2 is 4 amps. So we got I1 and I2. Once we get I1 and I2, we can automatically find R1, that is V by I1, that is 16.66 ohms, and R2 is 25 ohms. So this we have got everything from the figure 1. So what they are asking is, what is the current drawn when these two resistors are connected in series? So if these R1 and R2 are connected in series, we have to add. So 16.66 plus 25 will be of 41.66 ohms. So we got the total resistance. So current formula is I is equal to V by R. We know V 100 by 41.66. Therefore I will be 2.4 amps. This is what they're asking.